Assalamualaikum and good day to all. So this will be our first online lecture, continuing on the fourth learning unit, which is Acid Base Equilibria. Now these are the learning objectives that each and every one of you must accomplish. Okay, the first one is defining acid and base and their conjugate. Okay, means you should also able to define conjugate acid as well as conjugate base. Secondly is memorize relative strength of acid and base. So acid, there are many of acid, many of base, but they have different in terms of their strength. Okay, we have strong acid, okay, weak acid, strong base, weak base. The third one is to express auto-ionization of water. What does that mean? Okay, and how do you express it? Okay, the expression. The fourth one is solving pH of a solution based on the concentration of proton H plus and also hydroxy OH minus concentration. Next is solving pH of weak acid or weak base solution. Okay, and solving this you need the constant values, which are Ka or Kb, depending whether it's acid or base. Next is explaining buffer solution. What is buffer solution? Okay, and how do you calculate pH of a buffer solution? And then finally, distinguish the acid-base properties of salt solution. So if you are given any type of salt, you should be able to identify whether that particular salt is having acid property or base property. Now definition back in the old days, okay, by Arrhenius, okay, for acid, okay, he mentioned that acid increase proton concentration, whereas base increase the hydroxy concentration in solution. Okay, for example, if you have HCl, okay, so means you have there's an acid there, okay, H plus. And if you have NaOH here, okay, yeah, okay, you have OH, so there is hydroxy concentration. Okay, and also according to Arrhenius, when you mix acid with base, you will get salt and water. Now the problem or the drawback of the definition for acid and base by Arrhenius is it only limit to aqueous solution. Now if you have solid or water vapor, okay, you cannot use this definition. Okay, so therefore, now Bronsted-Lowry improved definition of acid and base by Arrhenius. Okay, he mentioned that acid donate proton, whereas base accept proton. Okay, now let us look at first at proton. Okay, proton in aqueous ion is simply proton with no electron. So in water, this proton ion form cluster. Okay, cluster mean they group with each other. I'm sure you're very familiar with the term cluster because what happened at the moment. Okay, now the simplest cluster is hydronium. Okay, H3O plus. This is the simplest cluster for proton in aqueous form. The larger clusters are H5O2 plus and also H9O4 plus. Now, however, in analytical chemistry, we normally use either proton H plus or hydronium H3O plus. So, if you see definition by Bronsted-Lowry, it does not mention anything on OH or hydroxy. Okay, okay, very simple definition. Acid donate proton, base accept proton. Okay, Now, if we consider this reaction here, we have hydrochloric aqueous form, hydrochloric acid, and water liquid, H2O. So which one will act as acid? Which one will act as base? Now we know, of course, this is acid because we know HCl. Okay. But what if water react with water? Later on we'll see. Now consider these two. So you see here, water here can behave as either acid or base. Okay. So we can classify water as amphoteric. Okay, because it can behave as acid as well as base. So in this case, we know this is acid because why? This proton is being donated to H2O. So donate it to H2O. Okay, donate to H2O. So it becomes H3O plus. So already added one proton here. Okay, leaving behind HClS, Cl minus. So this is acid, this is base. Okay. Now, next is conjugate. If you remember the previous reaction just now, okay, between water and HCl, okay, acid donate proton. Once it donate proton, it become conjugate base. Okay, so the Cl form just now, okay, Cl minus form is the conjugate base. Okay, so H3O plus becomes conjugate acid because it accepts the proton. Okay. I hope everyone is clear. If you're not clear, you can send me a message in the chat box. I will create a chat box. Okay. Or we can set one day for us to have a discussion. If you have question, you can ask me during that time. Okay, next we move on to the relative strength of acid and base. The stronger the acid, the weaker the conjugate base. Okay. H plus is the strongest acid that can exist, whereas hydroxy is the strongest base that can exist in equilibrium. Okay, so this table here shows relative strength of acid and base. Notice here, okay, at the top part here, acid is the strongest, whereas here consider negligible. Okay. On the other hand, if this is very strong, this is become negligible, whereas this part here, it becomes very strong. Okay. And in between here, we call them as weak acid and also weak base. So hydrochloric acid, sulfuric acid, and nitric acid, they are all classified as strong acid because they are 100% ionized in water. Means if you put this in water, the water become H plus and also Cl minus. Okay, no longer HCl inside. Okay, 100% ionized. Okay, that's why they are classified as strong acid. Same goes to strong base. They are 100% protonated in water. Moving on, next is auto-ionization of water. Okay. Now, what is auto-ionization of water? Now, pure water, you will have this equilibrium here. Okay. Water with water will give you hydronium and hydroxy. Remember, earlier on I mentioned that water is amphoteric substance, mean it can behave as either acid or base. So if you have water with water, one will act as acid, the other one will act as base, and it will form H2O plus and OH minus. Okay, let's say this become acid, this is acid, this is base. So this, on the other hand, because it donate proton, this become conjugate base. Okay, forming this. This one accept the donated proton here. So this one is base, this is conjugate acid. Now, we can write this autoionization of water in this form of here. We call this expression. Okay, K equilibrium. Okay, constant. Okay, equilibrium constant of water. So we put product on the nominator. Okay, reactant in the denominator. Now, because the reactant, the denominator here, are both in liquid form, we can ignore them. Okay, we can ignore them. Okay, that's why you see here, when you write the expression, you bring this over here, it becomes K equilibrium times H2O squared. Okay, equals H2O plus times OH minus. So we can ignore this. Okay, it becomes water ionization constant, Kw. What W refers to water, K is constant. Now, so Kw equals H2O plus concentration times OH minus equals 1 times 10 power of negative 14. Now you must memorize this expression here. Okay, you have to memorize. Next is pH scale. Okay, so pH comes from negative logarithm of H2O plus or H plus. Okay, whereas POH is the negative logarithm of OH, okay, hydroxy concentration. Now, in neutral water at 25 degrees Celsius, pH will be equivalent to POH, which is 7. Okay, in acidic condition, okay, the H plus concentration will be more than 1 times 10 power negative 7. So it means that pH will be less than 7. Basic, on the other hand, pH more than 7. And if you have 7, 7 means neutral. Okay, so the scale of pH will be between 0 and 14. Okay, however, there are no theoretical limit on the value of pH or POH. For example, here, pH of 2 molar HCl will be negative. Okay, negative. Okay, no theoretical limits. But when you do experiment, only falls between 0 to 14. Okay. Remember the autoionization expression of water. Okay, Kw. Okay, so pKw means you negative log the Kw. Remember, you have to memorize this Kw. Kw equivalent to 1 times 10 negative 14. Okay, resultant of H plus and OH concentration. Now, when you put it in the pKw form, you negative log 1 times 10 negative 14, you get 14. So pH plus POH, you get 14. Okay, next is calculation. how to calculate the concentration of hydroxy ion in 0.1 molar hydrochloric acid. Okay, how to solve this problem here? Now, first, write down whatever information given to you. Okay, so first, we are given 0.1 molar hydrochloric acid. What is being asked is concentration of hydroxy. Okay, so what we can do is we substitute this hydroxy in the Kw expression. Remember, Kw equivalent to H plus times OH minus, equivalent to 1 times 10 negative 14, the one that I told you to memorize. Now, if you substitute H plus, you substitute Kw value, you should be able to solve OH.